So, our today's topic is kind of going to start with GRE itself. So, you must be familiar with tunneling things, right? There are so many tunneling mechanisms. Our topic of today itself is going to start with tunneling. So, there are two terms, however. One is called as underlay, and the other one is called as overlay. Generally, when we look at, I would say, uh, deployments that are done in huge scales. So there are ways that are used in order to secure the traffic. So if you have around 10, I would say, networks there. Let me share rather my other screen so that I can write on the display.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Yeah, so we are gonna discuss something about overlay tunnels in that. Right? And in this overlay tunnel, we first gonna get an understanding about why do we actually need tunnels at the first place. So generally, when you kind of get an overview about LAN infrastructure or WAN infrastructure, when that LAN infrastructure is combined together with WAN infrastructure, the security comes in for a concern. So if you have a scenario where there are like a couple of routers, let's say, or just a single router, and then that router is connected to maybe a core switch, and in that core switch is inside the organization is connected to further smaller switches where there are endpoints connected, right? Like this. There can be numerous devices that are connected like that. And then you can have another core switch maybe that is connected to in a redundant way. And then there are furthermore access switches. Right? This can be an internal network there of your organizations. And the employees that are connected at this particular space needs to actually communicate outside the internet. So you might have your ISP connectivity, and then that ISP might be connected at some other probably site there. So this can be maybe your Dubai site, and this can be maybe your London site or somewhere else. And down the line, you also have your LAN infrastructure there. So from here to here, communication actually needs to be done. But in that case, the data needs to travel from here to the other side, right? And then in that scenario, this is not going to be a direct connectivity from point to point. There are going to be, I would say, tens or hundreds of routers inside of this particular space, which actually connects your point A with point B. So your traffic needs to probably go from another router to another router to another router to another router, and so far. So we do use BGP generally in order to make sure that different autonomous systems connect together by using some protocol or so. But the concern comes into play when you think about it according to the security point of view. So if your data is actually traveling on this particular public infrastructure, the data cannot be said as secure because your data is going to go through a lot of underlay devices. And if there are, I would say, source IP and destination IP that are exposed, then the information about that particular traffic and even data can be utilized in order to do some bad things as well. Because what you are doing is you are using private data to be sent onto the private site, but over a public infrastructure or but over a public route, you can say. So any user that intervenes the traffic that is flowing over that public transport can actually use that particular captured data for wrong intentions. And that's where security comes in play. So an overlay network, when you think about it, is kind of a logical or virtual network built over a physical transport. So when you look at the scenario over here, your ISP is not directly connected in a best way possible. We can redesign this particular thing in a way that all the ISP routers are with red there, 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 right? That's how the ISP Cloud, you can say, is clustered together. And then you have directly connected with one of the ISP Cloud, that's kind of going to be your entry point, and that's kind of going to be your exit point, right? Entry and exit, like that. And as soon as your traffic enters into the ISP Cloud, it is into the public infrastructure and not into the private infrastructure anymore. So this is where our data actually needs to be secure, okay, when it's traveling throughout that. So if you look at the networks that might be connected, maybe this is 12.0.0 something, then this is 23.0.0, then this is 34.0.0, 45.0.0, 56.0.0, something like that, right? That's how the IP networks can be. And when you are basically looking at the routing table there, you probably might have implemented something like NAT onto the outside interface, so that all the traffic that is coming in to go out onto the second side can get translated into the public IP address, and it can travel throughout. Because you're not gonna have your internal networks routed out onto the internet. That's not at all going to be possible. So when you do NATing and ACL and all these things, your traffic is kind of interesting traffic and needs to go out onto the public infrastructure and reach out to another private site there. But it is also going to travel through this particular link, which is called as underlay, right? Because it's going to reach out to all the physical devices there and make it to the next thing. So by using tunnels, you can create some logical connections that actually is connected from source to the destination, like over here. That's how the tunnel can actually be created. It's kind of a virtual gateway that your traffic will be flowing inside of this tunnel, and there won't be anyone who will be able to look into what's the information that is flowing inside of this tunnel. That's what the overall idea is. So when you look at an overlay tunnel, it is kind of a logical virtual link that is built over the physical transport. The transport is going to still be same, but it'll be a separate, I would say, a tunnel built up through which the data will be flooded. So overlay networks are used to overcome shortcomings of traditional networks by enabling network virtualization or things like that. Okay, and security is a major thing there that is considered when you look at encryption and encapsulation of things, or the data, whenever you're willing to forward your data onto the public infrastructure there. So there are different tunneling technologies that are available, one of which is called as GRE, okay, which is called as generic routing encapsulation. The second one is called as IPsec, which is IP security. The third one there is called as LISP, which is called as I would say locator ID or separation protocol. And the fourth one is called as VXLAN, virtual extensible local area network. And then the fifth one is called as MPLS, multi-protocol label switching. These are kind of the technologies that has been pretty much famous throughout for quite some time now. And MPLS has been at its peak when service provider deployment comes into play. So all of these do play a role in order to create something called a VPN, which stands for Virtual Private Network, which is again a form of tunnel that allows private networks to communicate with each other across an untrusted public network, which can be thought of internet, which can be your ISP backbone also. So VPN data is sent across from one side to the other side, okay, and all the information, as soon as the data leaves your gateway from here to here, is encrypted, which means nobody can actually see the actual content, the actual source, and the actual destination of your data when it is in this transit from here to here. It will not be able to see that particular data, whatever is traveling. Okay, and the most common VPN encryption algorithm that is used is IPsec. Okay, even advanced solutions like SD-WAN and all, or SDXS, allows you to build up automatic IPsec tunnels that would take care or that will facilitate the data plane connectivity of your devices there. Makes sense? So what we will be looking at the very first thing is we will be using maybe like one of the tunneling mechanism in order to check that how the configuration is done. We'll be using GRE. Okay, and inside GRE, or the example of generic routing encapsulation protocol, we're gonna see how physically routing like interior gateway protocols or even BGP can be taken care of in order to make sure that this particular device is reachable to this, and then we will be sending that particular traffic over a tunnel. So we'll be building up a tunnel from source to destination, and we won't be actually taking care of the complete routing there. We will simply be taking care of building up a tunnel and then mentioning a source and destination about how the things can be worked out there. Related protocols that actually secures communication whenever you are looking forward to communicate over the from one side to another side by using public infrastructure. So this purely is a VPN, virtual private network, where any transport can be used in order to communicate, and the source and destination, whenever the traffic actually leaves up, your traffic is completely going to be encrypted. So there was like need of communicating data packets securely over large public WANs, mainly like the ISP internet backbone. And the solution was to develop like many protocols, among which IPsec was one of the most deployed protocol, where it gains its benefits from the fact that it can easily be adapted without making any changes to the peers there. So when you talk about IPsec majorly contains two protocols. Okay, one is called as AH, which stands for Authentication Header, and the other one stands for ESP, which stands for Encapsulation or Encapsulating Security Payload. Okay, these are two of the most protocols that are there into IPsec. So when you talk about AH, in this protocol, which is authentication header, the IP header and the data payload is hashed. Okay, and from this hash, there is a new authentication header, or you can say a new header, which is built, and that particular header is appended into the packet. And this new header or the new packet is transmitted via the router, where the router kind of hashes the header and the payload both. So these hashes needs to be exactly matched, and every I would say thing inside the packet will kind of be hashed there. So you can call that double hashing thing. Double hashing is actually being used there. Your IP and your data is both hashed there, and they need to be matched. So when you talk about security, it's all about the CIA triad, right? Confidentiality, integrity, and availability. So this CIA triad is met when you use IPsec there by using either authentication header or by using ESP. But when you talk about ESP, then that's another security protocol which provides you encryption and integrity to the data packets. So the ESP is added after the standard IP header, which means that it contains a standard IP address, and it can be routed easily with the standard IP devices as well. That makes it, I would say, easily available there. So it does encrypt or it does use protocols like advanced encryption standards or DES, okay, or by using HMAX or Diffie-Hellman groups and all in order to encrypt your payload, in order to encrypt your data, and both the things. So by using encapsulation security payload or by using authentication header, you kind of secure the traffic that is going to flow over the public infrastructure. And then when you talk about how the encryption technologies works, then the encryption technologies works in two modes. So one of the mode is called as tunnel mode, and the other mode is called as transport mode. The tunnel mode, you can say that encrypts this basically tunnel mode encrypts both the payload and the header. So the IPsec in tunnel mode is used when the destination of the packet is different than the security termination point. Okay, and the most common use case of this particular mode is between gateways or from you can say gateway to gateway communication. So the gateway serves as a proxy for the host, and when the origin of that particular packet differs from the device that is actually providing the security, then the tunnel mode is used. And the transport mode is used only for the data portion of each packet, where only the data portion is going to be encrypted, and this mode is applicable between end stations or between end like station and the gateway as well. So site to site VPNs and all these particular things usually would be used there in transport mode or so. So that's kind of a couple of things that would be noticed over there when you work with tunnel mode and transport mode. And whenever the execution of IPsec is done, then the execution is as well done into two phases. So you have phase 1 and then you have phase 2. In phase 1, the IPsec negotiations are basically done. And in the very first step, the IPsec peers are authenticated by protecting the identities of the peers and so. And then the IKE, Internet Key Exchange, comes into play. And these basically like negotiations are done. So it might be possible that whenever at one end over here and the other end, and you need to create a tunnel between these two. So over here, when you do the IPsec configuration, you need to choose what hashing mechanism you're using, what encryption protocol that you're using, and what all are the other parameters that you're using maybe, right? Those same things also need to be taken care of at the configuration on the other end, hashing, encryption, and all these things, right? The phase 1 takes care of doing the negotiations over here when you actually work up according to the thing. And if the particular parameters matches up, then the IK, like the phase 1, creates something called SAs, which stands for security associations. So the security association is created. It means that handshake has been done, everything is matched up, and you can move on to the second phase over there. That's kind of the information that is actually. Wait. So wait a minute. Security association is negotiated. Okay. That negotiation actually will take care or will take part into phase 2. Yeah. Phase 1 actually deals into two modes there, where main mode will be taken care of or aggressive mode will be taken care of. I'm sorry about that. So basically just IKE parameters, which mean public private key infrastructure or internet key exchange, will be taken care of, where that the IKE will take care of I would say doing the handshake between those devices by exchanging the keys and all. So there are two modes, like the phase has two operating modes there. One is called as main mode and the other one is called as aggressive mode. So in main mode, there are three exchanges amongst the initiator and the receiver. The first thing is basically algorithms and all are exchanged and hashes are exchanged. And the second exchange is responsible for generating the secret keys by using Diffie-Hellman and all. So main mode takes care of exchanging the algorithms, the hashes, and what Diffie-Hellman group are you using in order to secure your thing. And then after that, you have aggressive mode, and there are fewer exchanges that are done. So it is not that complex as the main mode, because main mode goes through all the exchanges there, and once it is ensured, then and then only it will move on to the second phase. So aggressive mode is quite, like I would say, casual. It doesn't look into the detail that particular deeper. But the only trouble is that the information is shared before there is like a secure channel making this particular mode vulnerable. So aggressive is not that secure as the main mode is. And then after that, once the parameters are set for algorithms and hashes and what Diffie-Hellman group is being used for encapsulating and encrypting the traffic, then you move to the phase two, where the like negotiations for forming of the security association is done. So here, as well as like IPsec policies are shared and then established the IPsec security associations. So there is only a single mode which is called as quick mode in phase two. And in this quick mode, it exchanges the information or it exchanges the negotiation protocols that has been set up by matching those particular thing up. And then this is where security associations will be formed and the IPsec tunnel will be created there. That's how the process actually works up. So you configure whether you want to use AH or whether you want to ESP. Then after that, you configure whether you want to use tunnel mode or you want to use transport mode. And then after that, you configure all your phase one, phase two characteristics, and then your tunnel will kind of be bought up. That's what generally the process would be.